So yesterday we found the zeros, and we did that by factoring. We started by factoring the things, and whatever polynomial we had, we factored it, and then we set each one of those factors equal to 0 because we knew that if one of those things equaled 0, then the whole polynomial will equal 0. So today we're going to talk about something called multiplicity. Multiplicity is how many times that factor shows up. So maybe it's more than once. For example, if we've got r minus 2 and r minus 2 equals 0, then we would know that we would go r minus 2 equals 0 and r minus 2 equals 0. We would add 2 to both sides just like we did yesterday. And we would get r is equal to 2. And we do the same thing over here, and we would get r is equal to 2. If you notice, the same number appeared more than once. So yesterday I was like, well, you don't have to do the same work twice, but we should acknowledge that this answer has appeared twice. So we would say that this has a multiplicity of 2. So because it appears 2 times. The number 2 appears 2 times. I almost wish I had used a different number like 4 because it's like the multiplicity talks about how many times it has happened. So here's why we care about it. So I just got done teaching the SAT course for math for those students who were doing it. And one of the things they looked at is what does a graph look like? Like they had a polynomial and they were asked to determine what the graph looked like just based on using the zeros or the solutions. And one of the things that we know about the multiplicity is that when something has an even multiplicity, if that is an even number, like a multiplicity of 2, this graph will touch the x-axis, but it won't cross it. So even multiplicities means that, for example, here, if -3 is one of the answers and it has a multiplicity of 2, just like ours, for our example, had 2, it's going to come up to that point and touch it, but it's not going to cross it. But when a root has an odd multiplicity and it's greater than 1, then the graph bends as it crosses. So if you notice here, 0, right here at 0, has a multiplicity of 3. So as it's coming here, it bends like that. So the question is, does it cross the x-axis or does it just touch the x-axis? And that's determined by whether it is even or whether it's odd. So if it's even, it just touches the x-axis. And if it's odd, greater than 1, then it bends as it crosses. So we're going to take a look at some problems here and see what that would look like. So here's what you might see when it comes to test time, when it comes to multiplicity. It says, identify the roots of each equation and then state the multiplicity of each root. So let's do this just like yesterday. Here are 3 factors, and we want to figure out where they equal 0. So how would I do that? Just like yesterday. How would we go about that?
You make x plus 3 equals 0, and then you subtract 3 from both sides. And that's x plus -3.
Okay, so one of my roots is -3, and then what?
The second one, x minus 2 equals 0, and you add 2 on both sides.
Add 2 to both sides.
And then x equals 2.
Okay, so x equals 2 as a root.
And then the second one, the last one, x plus 3 equals 0.
Notice this is the same as the first one. Subtract 3 from both sides, and we get x is equal to -3. So we basically have 2 answers here. We have x is equal to -3, and x is equal to 2. However, there is a multiplicity of 2 meaning something is happening twice. This one and this one is happening twice at x equals -3. It just means that -3 appears as an answer 2 times. At -3, we're going to have this graph coming up and touching the x-axis because that is an even number. Because it's an even number, if you were to look at -3, it's going to go up and just touch the graph, but not cross it.
That'll be the answer of it.
Yep.
Multiplicity of 2.
Right, so it's got a multiplicity of 2 at x equals, multiplicity of 2 at, not a, at x equals -3. Now B looks harder than it really is. There's a lot going on here. Like it is y plus 4 to the third power. It is y minus 2 to the second power and y plus 1 to the first power. We could distribute, but really what this means is this. We've got y plus 4 and y plus 4 and y plus 4. Well, we're not there yet. Let's get there. Let's get there. So we've got y plus 4 3 times. We've got that as a factor 3 times. And then we've got y minus 2 as a factor 2 times. And we've got y plus 1 as a factor 1 time. So notice that there are 3 of these, right? So we've got y plus 4 is equal to 0. We could write that 3 times if we want to, but just remember, this is happening 3 times. So we're going to go minus 4, y is equal to -4. Now that -4 has a multiplicity of what? Of 3, meaning it happens 1, 2, 3 different times. Now y minus 2 equals 0. That happens twice. So we're going to add 2, we're going to add 2, and we get y is equal to 2. So y equals 2 and y equals -4 are both answers. Y equals -4 has a multiplicity of 3, and y equals 2 has a multiplicity of what? Of 2. It happens twice. Then we've got y plus 1 equals 0. Subtract 1 from both sides, and we get y is equal to -1. And it has a multiplicity of what? Of 1. It only happens once. So if you were to look at this on a graph, what would this look like? Well, here, this has at x equals, sorry, that looks like a y. X equals, oh no, this is y. I'm sorry, it is y. My apologies. At y equals -4, we have a multiplicity of 3. Y equals 2, we have a multiplicity of 2. And y equals 1, we have a multiplicity of 1. So we could expect here at 3, since this is odd, that it would bend and cross. Multiplicity of 2, we know that it will not cross. So this is not going to cross the x-axis. And a multiplicity of 1, well, it's not going to bend, but that is going to cross as well. Don't worry about that one, because really what we're talking about more is, what about those 2's and the 3's? 1, when we've got a multiplicity of 1. So mainly we're looking at here is the multiplicity. That's the only thing that we've added on since yesterday is what is the multiplicity? And we're going to just keep doing problems, keep doing multiplicity, but you're going to see that in a few problems from now, it starts to get kind of ugly because factoring does not become easy. Yes, ma'am?
What does it do when it's even for the graph?
So look right up here. So when it's even, where'd it go? When a real root has an even multiplicity, the graph touches the x-axis but does not cross it.
And if
Well, you're not going to graph it. You're not going to graph it. I'm just talking to you, so like what this means for you. Like what is a multiplicity of 1, 2, 3? What does it look like? So you're not going to be asked to graph that.
Is there going to be a graph on the quiz?
Well, right now all we're doing is like solving them. Like, so we are getting to a point where we're going to do that, but right now all we're doing is talking about multiplicity. All we're just talking is what is the multiplicity. So we'll get there.
We don't need to worry about the graph for now.
Not now, no. I mean, you might be asked to talk about it. Does it touch the x-axis? Does it cross the x-axis? But you're not at a point where we're graphing it yet. Okay, let's go on to... Okay, so I could write this out 5 times again if I want. Like I could sit there and write this out x minus 1, x minus 1, x minus 1, x minus 1, x minus 1. But do we agree that there's 5 x minus 1s there? Okay, so let's just agree that we've got x minus 1 equals 0 5 times. That's going to happen 5 times. So I'm going to add 1, and I'm going to add 1. And Ozzy, you came up with this a minute ago by looking at this. You said, so what is that multiplicity? Yeah, x equals 1 is a solution, and it has a multiplicity of 5. So let's save ourselves all the time of writing x minus 1 over and over and over again when we're just doing the exact same work over and over. We already know what x minus 1 is equal to. We did it once. Let's try x plus 6 equals 0. We're going to get minus 6 minus 6. And we get x is equal to negative 6. And x is equal to negative 6 will have a multiplicity of what? Of 2. Now, at one of these two areas, it's going to touch the x-axis, and one of these two areas, it's going to cross the x-axis. Which one is which? So at x equals 1, something happens, and at x equals negative 6, something happens. One of them touches the x-axis, one of them crosses the x-axis. Which is which?
The first one crosses it.
Right, so just so you get an idea of what it's going to look like, that crosses the x-axis, this touches the x-axis. Just kind of touches it. And then last but not least, we have one more, x minus 10. X minus 10 is equal to 0. Add 10, and we get x is equal to 10. And that has a multiplicity of 3. If I were to look at the graph at x equals 10, what would I expect to see around that area? What would the graph be doing at that area? It would be crossing the x-axis. That's what I would expect to see there. This is what I mean by like, what would this look like? It gives you an idea of what's happening at those points. So it gives you an idea of those things. Okay, that was C. Let's move on to D. All right. Let's talk strategy here. Let's take a look at this before we just start going at it. Let's take a look at this because there's some things that we might want to notice before we start. Yes, sir.
There are 2 pairs of x minus 7 and x plus 3.
X minus 7, x plus 3. There are 2 sets of those.
So like what you can do is that you can just say x minus 7 squared.
Okay, we could rewrite it like this.
And then x plus 3 squared. And then just put that plus 7 plus 5. Just to make it more organized.
Just so that when we do our work, if we wanted to, it just helps us kind of see where we're going here. Like I've got 2 x minus 7s. I've got 2 x plus 3s. All right, what now?
Then you do x minus 7 is equal to 0. And you just add 7 on both sides, which makes x is equal to 7. Which has a multiplicity of 2.
Has a multiplicity of 2.
Makes it even touches the x-axis.
Perfect. So multiplicity of 2. So it's going to touch the x-axis at x equals 7. All right?
And then you do x plus 2 is equal to 0. Then you just subtract 3 on both sides. And you get x is equal to negative 3. And then that also has a multiplicity of 2. So it'll touch the x-axis on
I'm just going to write mult at this point just to save us time. So of 1. I don't want you guys, I'm sorry, multiplicity of 1. There we go. I don't want you guys to abbreviate it. I'm just trying to keep up here. So
Then you do x plus 5 is equal to 0. Then you subtract 5. You get x is equal to negative 5. That also has a multiplicity of 1.
all right, so we get an idea of what this graph would look like. It's going to do something at x equals 7, something at x equals negative 3, something at x equals negative 7.
Multiplicity of 2.
Did I?
Negative 3.
Which one?
Yeah.
Oh, I'm sorry. Thank you. It's got a multiplicity. Sorry.
Is there a multiplicity of 2?
It does have multiplicity of 2, yep. My hand was writing faster than my brain was working. So we've got 2, 2, 1, and 1. Gives us an idea of what's happening there. So, all right, now we get into some situations that aren't so pretty. And you'll see why in just a moment. Let's look at E.
So technically, if the multiplicity is 1, it would cross.
Right, it's just not going to bend. Because here's the thing. When we talk about a multiplicity of 1, that it's like x plus 1, that's like the graph of a line. And remember when you graphed lines in Algebra 1, they were always like straight lines. Okay, so let's talk about this one because there's kind of a lot going on here. But I think we know how to attack it until we kind of see what's going on. Something here is going to become real fishy. Let's do grouping. All right, let's talk about this first group here.
5x squared.
X, take out x2.
What do I have left inside?
X and
Is that the difference of squares in there?
no.
No, it's not. Because the x is not squared. All right?
And this one's
You get
27.
Pull out a 27. And what do I have left inside?
Lauren Fielding, report to student services. Lauren Fielding, report to student services.
We didn't do anything wrong. We didn't. We all felt like that, like we didn't do any bad math there, right? I mean, our math is correct, right?
Yeah.
But why am I not happy with where we're at? Right. We can't use this as like a factor here because something is not matching up there. So I'm like, okay, this is not matching up. So when we run into this situation, there's something we can do. That we can figure out how to decide what the factors are. It's a little bit longer, but let's look at negative 27. And let's come up with the factors of negative 27 for just a moment there. We're going to look at the constant term, the one that is just a number, no variables, just that one. So let's talk about what the factors are, but we're not going to try to make it add up to anything. I just need a list of the factors here. Let's start with 1 times something. What would 1 times what?
Negative 27.
Okay. Just 2 times anything, will that give me 27? Okay, how about 3 times something? 3 times negative 9. And then 4, 5, 6, 7, 8, 9. Then it looks like the only other ones we're going to get is negative 1 times what?
27.
Times 27. And then negative 3 times?
Positive 9.
Positive 9. So here's the possible factors we can work with here. So what we're going to do is we're going to take a look at these numbers right here. And we're going to check to see if any of them are factors. Now remember, I told you a while ago how to check if something is a factor. One of the things that we did was we used synthetic substitution to do that. We looked at these right here and we grabbed the coefficients. We said 1, negative 9, 27, and negative 27, and negative 27. And the first number I'm going to try is 1. If 1 is a factor, what will be true about the remainder over here? Remember we did this and we said something will be true about the remainder when I'm done if it is a factor. Yes, sir.
Why is it a 1?
Because x is equal to 1. We've got x is equal to 1. We're not going to do that opposite thing because we don't have x plus 1. We've got x is equal to 1. That is what x is. Before we did it like this, we to check, like when we did division like this, we had to use the opposite of that number because we said x minus 1 is equal to 0. Then we added 1 to both sides. So we're going to try 1. So what would be true about the remainder if 1 is a factor? It would be 0. Remember, we tried this, and if this ends up as 0, then it is a factor. So the first thing we're going to do is bring down. And then what did we do when synthetic substitution like this? Same thing. Same thing we did. Multiply. 1 times 1 is? Negative 9 plus 1. Negative 8. 1 times negative 8 is? And then what is 27 plus negative 8? Positive 19. 1 times positive 19? This is negative 8 remaining. So is 1 a factor of this? No, unfortunately not. That would have been nice and easy for us if it was. 1 is not a factor. So let's go and try 3 now. Let's try 3. We've got 1, negative 9, 27, negative 27. And we're going to try the next number in this list. We're going to try 3 to see if it's a factor. So we're going to bring down 1. 3 times 1 is 3. Negative 9 plus 3? 3 times negative 6. Negative 18. Sorry, that ends up as being positive 9. 3 times 9? 27. Negative 27 plus 27? 0. Which means that 3 is definitely a factor. X equals 3 is one of our answers right there. So x equals 3 is definitely one of our answers. So here's what we've got now. This is what our equation looks like. This is the secret right there. We've got x is equal to 3. So if we know that there's x equals 3, then what we've got left over here is 0 remainder. We've got, this is our constant, that's 9. We've got x to the first power and x to the second power. If I rewrite that, it's x squared minus 6x plus 9. Now that I can factor. We already know that this is one of the answers, that x equals 3 is one of the answers. But here's what we have left over is that. Once we found out that x equals 3, this is what was left over. So how do we factor that? Let's split it up. And what am I looking for?
Something that multiplies to 9 that adds up to negative 6.
Okay, two numbers that multiply to equal 9 that add up to equal negative 6. What are those two numbers? X minus 3 and x minus 3. So we're going to set those equal to 0 real quick. I'll get to your question in just a second. Give me 1 second. X minus 3 equals 0. What am I going to do? Add 3. Add 3. And x is equal to 3. Notice we already had that answer. That's twice that we've got that answer right now. And when we do this one, x minus 3 is equal to 0, we're going to add 3 and add 3. And we got x is equal to 3 a third time. What this tells me is that x is equal to 3. That's the only answer. And it has a multiplicity of what? 3. 1, 2, and that first one we found up there. Multiplicity of 3. Yes, sir?
How did we get x squared minus 6x plus 9?
So remember when we have the remainder, this is like when we looked at this right here. This, we have 0 remainder, x to the 0 power, but x to the 0 power ends up being what?
Oh, I forgot about the x that you did there.
Got it now?
0 x squared.
Right, x to the 0 power becomes 1, and 9 times 1 is just 9. That's this. And then negative 6x is right here, and x squared is right there. Trust me, we're going to do a bunch of these, so don't worry. Like, I realize that these are the hardest of it. When you talk about what you're going to be dealing with on Thursday, this is the hardest of it. If you can factor, I'm going to be giving your quizzes back. When you get those back, so you're going to see what you missed on those, but this is going to be the hardest part in my opinion. Okay. let's talk about this next one here. So we found one of the factors up here, right there, is x equals 3.
Oh.
And then what was left over was this amount right there. And when we factored that, there ended up being 2 more 3s. So 3 3s altogether. So if you think about that, there was an x minus 3, an x minus 3, and an x minus 3. 3 times. That's what it looked like. All of that equaled 0. That's how it broke down.
So the one at the top, like first step,
Mm-hmm.
the reason why we found we had to find factors at negative 27 is because it wasn't allowed.
Because this didn't work out the way we wanted to. That did not match up, and we got stuck. The very first thing I would do when that doesn't match up is check my math. Like, I would check my math because I'd be like, did I make a mistake? Because if I didn't make a mistake, then I need some other kind of backup, and that's where this comes in. You go, okay, this stinks. That didn't match up. Brooke?
So when you're checking the factors, you only have to check them until you get one that works.
Right. Once we pull out a factor, like let's say this is a factor right there. We figured out this x is equal to 3. Sorry, it's kind of slow picking up here. Let me see if that speeds it up. Once we knew that, of course the screen's a little slow there. Once we knew that x is equal to 3, there the highlighted red thing, the green text with the highlighted red, then we knew that if x equals, really what it tells us there is that we've got x minus 3 is one of them. That's what we just found out. That's a factor. That 3 is a factor. And what is left over after that was x squared minus 6x plus 9. And this we could break down, and this we could break down. That's what it did for us.
And when you broke that down, that's where you got that.
Right.
X minus 3.
Right, this became x minus 3 and x minus 3, and we still had that original x minus 3.
Where'd you get the first x minus from the top?
That first factor that we figured out, when there was 0 remainder, we figured out that was a factor.
Okay.
Can we try another one? I know there's a lot of questions, but if we try some more, that a lot of people will be like, okay, I get it.
It's just a what if none of those numbers work with the negative 27 you split up?
So if none of the factors work, there's actually another method we're going to learn for factoring as well. It's a lot of factoring. Okay, let's talk about this one. Anything that we can do in the beginning?
Could pull out a 2 or a negative 2.
Okay, let's pull out a negative 2. Let's definitely do that. Let's pull out a negative 2 to the front because they all share a common factor of negative 2. I'm going to leave myself a nice big parentheses there because I need like 4 things that have to go in there. What's left inside afterward?
X cubed minus 6x squared plus 15x minus 100. No, wait, minus 15x. So.
Isn't it plus 6x squared?
Oh, yeah.
Minus 15.
Okay, plus, minus, and what is my last number?
Negative.
Now, we could try grouping this. We could certainly see what's going to happen here. Let's try, this inside there, right? We need a way of dealing with that. We could try grouping it. So let's try that. Let's see where that takes it.
Question.
Yeah.
Can you separate, let's say, the x cubed from the 6x squared minus 15x minus 100? Like,
The 6x squared. I'm sorry, tell me again what you want to
can
do?
you separate the x cubed, like put it in a parentheses outside and then put it in another parentheses?
You can only pull this out there if you are pulling it out of everything. If you're factoring it out, it's got to be in everything. So what you're pulling out is something that's common to each of those things. So let's check this real quick for grouping like there. Let's see if we can group this. Yeah, because we need a way to factor this. So let's see if we can group it. In this case, what do those two things have in common? I'm going to leave this negative 2 out front. It's just staying out front there. So these two have in common an x squared. What would be left inside? And what do these two things have in common? Negative 5.
And then it would be x plus 20.
X plus 20?
Oh, yeah.
So you see how we're running into the same situation again? We're going to keep running into this situation where we're like, dude, grouping isn't working. That stinks. Like, I keep running into the situation, and that's like, well, what do I do now when grouping fails me? Because, like, I haven't run into this situation yet. And that's where we go back to using synthetic substitution. So let's look at the constant. And the one that we're going to look at here is, since we've already pulled out a 2, that's great. Let's that's not a highlighter. Let's make our life easier. We've got that 2 on the outside. Let's look at factoring what's inside there. What are my 2 factors of negative 100? Now you might be like, why didn't I use 200? Because I already pulled a 2 out. I made it smaller. So let's just work on factoring what's inside the parentheses. So let's talk about factors of negative 100.
Why do you have to use 100?
So we always use the constant when we run in here. We're going to look at the constant, the one that does not have a variable on it.
Oh, okay.
Just like we did in the last one. Find the one without a variable. That's what we're going to use.
-10%.
Okay, but let's start with, let's make a sequential list. Just because you know what we're going to have to do. We're going to have to do a bunch of numbers here. So 1 and what?
Negative 100.
And then we've got 2 and?
Negative 50.
Okay, and does 3 go into it? 4?
Yeah. 25. Negative 25.
Okay, 5?
-20.
6?
No.
7?
No.
8?
No.
9? 10?
Yes.
All right, let's check these. If we need more factors, we'll check for more, negative 10. We'll check for more factors if we need them. We're just looking for 1. If I can find a factor, I can make this a lot simpler on myself. So let's decide whether 1 is a factor. And the way we do that is we are going to take these numbers that we use here. We made it smaller so that we can make our lives easier. Otherwise, there was no purpose of pulling that negative 2 out. So the numbers I'm going to use are 1, 6, negative 15, and negative 100.
Why do you pick those numbers?
Because I'm using, this is what I'm trying to factor right here. And those are the coefficients.
Oh, I see. Okay.
All right, so what number should we start with out here?
No 1.
Let's try 1. 1's super easy to work with. Let's bring down our 1. 1 times 1 is 1. 6 and 1 is 7. 1 times 7 is 7. Negative 15 plus 7 is a negative 8. 1 times negative 8 is negative 8. And this has a remainder of negative 108. Is 1 a factor? No. Okay, let's just keep moving. No point in wasting our time with things that are not a factor. So I'm going to use, again, 1, 6, negative 15, negative 100. Guess which number I'm going to check next? 2. And again, I'm just going to try to not spend too much time on this. Bring this down. 1, 2 times 1 is 2. 6 and 2 is 8. 2 times 8 is 16. That gives me 1. And 2 times 1 is 2. This is negative 98. Is 2 a factor? No. What am I going to move on to next? 4. So we've got 4, 1, 6, negative 15, negative 100, using the same numbers out front each time. 1. 4 times 1 is 4. 6 and 4 is 10. 4 times 10 is 40. Negative 15 plus 40 is a positive 25. This looks promising here. 4 times 25 is 100. What is negative 100 and 100?
0.
Amen, because now we finally got what we need. We know that x equals 4 is a factor. And here's the best part about that. X equals 4 is definitely one of our numbers. I'm marking that because that's definitely one of the things I need. Here is my remainder. Here is x to the 0 power, x to the first power, x squared. I'm just going to rewrite this down below. X squared plus 10x plus 25. Is that something I can factor?
Yes.
Okay, so let's factor it.
You do the perfect square triangle.
Okay? Or I could just look for two numbers that add to give me 25. It'd be 5 and 5, positive 5 and positive 5. So, x plus 5 could equal 0. Subtract 5, x would be equal to? There is another answer. X equals 4 is an answer. X equals negative 5 is an answer. I don't really need to redo this work here. What is this going to end up as? X equals what? Right, because we just did that right here. X equals negative 5. There are only two answers here. I have boxed, circled in 3 different things. One of them is equal to 4, and the other thing is equal to negative 5. But why do I have 3 things boxed in or circled, but I'm only writing 2 answers?
Because x equals negative 5 is twice, so it's like multiple.
It has a multiplicity of 2, meaning that answer occurs 2 times. So we're not ignoring it. It's just there's only 2 answers that come up, 4 and negative 5. 4 has a multiplicity of what?
1.
2 answers. One of them occurs twice. One of them occurs once. Yes, ma'am.
For F, why didn't you group it in the first place instead of dividing it by?
We tried grouping, so we did. That's actually the first thing we did, and we got here. This is what happened. We got x plus 6 and 3x plus 20, which was a disaster for us. As long as I feel like my math is correct there, like I did it over and over again, and it's not matching, I need something else. Because all of the other times we did grouping, they matched, and that was great. Okay, I could factor it. But when we run into this situation, we go, well, they don't match. What do I do now? Yes, sir.
So, you know, you did the negative 100, you can't find the 2 numbers and multiply to it a bunch of times.
Say it again.
You know, where we pulled out the negative 100 because the grouping didn't work.
Right, that's here, yeah?
Would it be really a big deal if you were to switch it from negative 100 to 1? I'm just curious.
From negative 100 to...
Like you flip the 1 and the negative 100 and the negative 50 and the 2 and the
Oh, you mean like the positive and negative numbers? That's what I would have done next. If none of these worked, that would have been my next bet. Yeah, I would have gone negative 1 and 100, negative 2 and 50, negative 4 and 25, negative 5 and 20. But the thing is I don't need to try all of them. I just need to find one that works.
So why can't you do negative 10 or negative 20? Just out of curiosity.
Because negative 10 times negative 20 is not... Negative 10 and negative 20?
No, I'm saying why can't you put negative 20 as something you can use for synthetic division?
We could. I just went in the list in order. We do have negative 20 as a choice that we could use. My point is that if we use negative 20, our numbers are going to get really big. Let's start with some of the easy numbers first. Because when we start using big numbers, things get big, right? You multiply big numbers, you get big things. And I'm not going to lie, I'm trying all the easy numbers first. So let's try the easy stuff first. And if we get trapped in a corner and none of the easy numbers work, then you're right. I'm going to have to try negative 100 and negative 50 and negative 25. But I really don't want to do that. So I'm avoiding that as much as I can. All right.
Oh, I have a question.
Yep.
Never mind.
Okay. I think we can squeeze one more in. There's only 2 problems left, but I think we can one more in. All right. This is crazy here, right? I mean, there's no GCF, right? There's no GCF there. They don't all have x's. They're not all divisible by 2. So I don't even have that going on. So maybe I would have even said 8, except for the first thing doesn't have an 8. And what's the problem with grouping here? There's 5. So here's what I'm going to do. Yep.
Can you use the one where it separates into a binomial and then a trinomial?
So that's when we do the sum or difference of 2 cubes.
Yes.
But we don't really have that situation here. So what we do in these situations is, let's say we need to find the factors of this, but we haven't been given a method for this at this point. So what we're going to do here is we're going to look at 16. Remember that constant term? That's our key right there. And luckily, 16 is not a huge number. If it were a huge number, there'd be more factors. So let's come up with some factors of 16 to see if we can narrow down what the factors could be. What things can I multiply to get 16? 1 and 16, 2 and 8, 4 and 4. Now there's negative ones too, right? There's 8 and 2. We could reverse these. We could use the negative ones. But let's try the easy ones first, yeah? Let's try that. So let's look at 1. So we're going to try 1 first. So the numbers out in front, we're using these numbers here, just like we always did. We've got 1, we've got -8, we've got 24, we've got -32, and 16. Bring down. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. 24 plus -7 would be a positive 17. 1 times positive 17 is 17. And just for the speed of things, you're going to have to trust me that these two things, when added together, are going to be -15, in case you didn't have that right there. 1 times -15, -15. What is 16 plus -15? Is 1 a factor? No, because it has a remainder of 1. We want a remainder of 0. Guess what the next thing I'm going to check is? 2. Using the same numbers, 1, -8, 24, -32, and 16. Where did I get those numbers? 1, -8, 24, -32, and 16. Where did they come from? They're from the original equation. They're the coefficients, the numbers right out in front there. So we've got 1. 2 times 1 is 2. -8 plus 2 is -6. 2 times -6 is -12. That gives me positive 12. 24. -8. 2 times -8 is -16. I'm very happy about this. This is a 0 remainder right there, which tells me that x equals 2 is one of my factors. From there, here's what we've got. We've got a 0 remainder. We've got x to the 0 power, x to the first power, x to the second power, x to the third power. So this part down here looks like this. X to the third power minus 6x squared plus 12x minus 8. Now, I'll tell you what, I've got two options here. We can check this for grouping, right? Because there's 4 things. We can check this for grouping, or we could just do synthetic substitution again. What do you want to do? I don't care which one. Let's try it. Whatever you want to do. Okay, let's see if grouping works on this one. Because why not? Maybe it does work. We already know x equals 2 as a factor. That's important. So let's group these together. What can be pulled out of that? X to the second power. And then I get x minus 6, yeah? Okay. Then what am I going to pull out of these two? A 2. Oh. Okay, good. Let's pull out the biggest number. That's certainly important. 4. What am I left with inside?
3 plus 2.
Ugh.
Minus 2.
This stinks. I'm upset again because, look, it didn't match again. So guess what I have to do? Another round of synthetic division because I can't break that down yet. So here's my constant. -8 is my constant. What are the factors of -8? Give me some numbers.
1 and -8.
1 and -8. What else?
2 and -4.
Anything else? We could reverse them. We can swap them back and forth. But basically, that's it for us. So let's look at that. Let's decide. Let's use our numbers. We've got 1, -6, positive 12, and -8. What's the first factor I'm going to check? Okay, so 1, which gives me 1. Oh, sorry, bring that down. 1. 1 times 1 is 1. This becomes -5. -5. 7. This becomes -1. Is 1 a factor? No. Guess what I'm going to try next? 2. Okay, so we've got, 2 that we're going to check. 1, -6, 12, -8. We already know that 2 is a factor, but we need to know whether 2 is a factor again. It might be a factor again. 2 times 1 is 2. That becomes -4. 2 times -4 is -8. That becomes positive 4. Positive 8. Which means now that 2 has become a factor a second time.
I have a question.
Yep.
I realized this. When we did the grouping for the second part, one of the terms was like, okay, so the terms inside were x minus 6 and 3x plus 2 and above, and then the terms that weren't used were x squared plus 4. And then I realized that, like, that turns into, like, if you brought it down to the answer that we have now, it's 2. So can't you use that?
I'm not really sure what you mean. I'm sorry.
So at the beginning, we...
Here, way back up here?
No, not that far. After we
Here, this part in parentheses?
Yes, after we tried to
And grouping did not work.
for grouping didn't work for the after we did synthetic substitution for the first time.
Okay, and we realized that then we were here, x is equal to 2.
After we split up all the terms and everything,
Mm-hmm.
there was a term, because you know how there's two sets of parentheses,
Yeah?
and those two inside are supposed to match,
Yeah.
and they didn't.
They
so
didn't.
We went back to synthetic.
Synthetic division again.
How about the
I'm
term that isn't used, the one outside the parentheses, like, because you know how there's.
Which one was outside the parentheses?
It was x squared plus 4.
The ones that you pull out, the ones that you saw.
These right here, these are here. We already know that those are factors. So we've got this. We've got an x minus 2 as one of the factors. X minus 2 is another factor. We've already got those. We've accounted for those. Like, it would be like if I said, what are 3 numbers you can multiply to equal 100? And you've identified 2 of them. We're just looking for the rest now. So we already know that x is equal to 2 and x is equal to 2. It happens twice. But now we're just coming down here, and we got here again, now to another 0, where there's a 0 remainder, and x to the 0 power, x to the first power, x squared, which is x squared minus 4x plus 4. Can I factor that? Yes, this is actually super nice. All that work finally gets us here. What can I do? Okay, so we get x minus 2 and x minus 2 equals 0. Now what? X minus 2 is equal to 0. That's add 2 to both sides, and we get x is equal to 2. Guess what? X equals 2 appeared again. And guess what's going to happen right here? X minus 2 is equal to 0. Add 2. Add 2. Add 2. And we get x is equal to 2 a 4th time. Now it's completely factored. We had 1, 2, 3, 4. X equals 2 was the only answer that popped up, except for how many times did it appear? So it has a multiplicity of 4. That's, in my opinion, the hardest problem. That took a lot of work, yeah? But it's a way of factoring as we go through things to find a factor. We wanted to know if something is a factor. Well, if it is a factor, then it has a remainder of 0 when we use synthetic substitution. We're not going to get through the last one in the remaining time, but were there any questions on this one?
What about the one that doesn't have a constant? Like
Up here?
the next question, it doesn't have a constant, the next letter.
Okay, so in this one here, we could look at the, what would we do on this, you're saying? Well, first thing we would do is pull out something, yeah? Okay, well, what would we pull out first? Okay, we'll take this as far as we can before the time runs out. 2x to the third. What would be left over?
Minus 11x squared plus 24x. Yeah. And then plus 36.
Do you see how we have a constant now?
Yeah.
So the constant doesn't appear at first, but it does once you factor out that 2x to the third power. In which case, we'd still go through the same thing. If you want, you can check it for grouping. I'm going to tell you right now, if you try h, it will not work with grouping. You're going to be forced to use synthetic substitution to find a factor. Once you know the factor, then you can see what you have left over, see if you can factor it. If not, synthetic substitution again.